officially welcoming you all in Google I/O extended by GDG Adelaide. This is our third session here. So before starting, we would like to acknowledge the traditional custodians of the warrior lands on which we live and work, the Gona people of the Adelaide Plains, and pay our respect to the elders, both past, present, and future. So, moving forward, I would like to welcome Geshan Manandhar, which is our first speaker for today. So he's a Google developer expert as well, and a senior software engineer at Simply Wall Street. And today, he's gonna present on a talk, You Build It, Google Run It Serverlessly in Containers. So please come on.
You can never solve a problem on the level on which it was created. That's a quote by Albert Einstein, and you'll know the significance as I go through. Today, I'm going to talk about You Build It, Google Runs It Serverlessly in Containers. Hi, I'm Geshan Manandhar, a senior software engineer at Simply Wall Street. I've been a GD since 2019 for Google Cloud Platform. GD is Google Developer Expert, for people who don't know it. I recently became a Docker captain. They haven't listed me on the website. Let's see when that will come through. I am also one of the GDG Cloud Sydney co-organizers. And I've been using Docker since 2014-ish. And I have dabbled with Kubernetes since 2015. Before I move ahead, can I see a raise of hands of the people who have used Docker? Or know about container technology? Nice, some of the people. And people who have used Kubernetes in some way or form? Or know about it? Not many, probably. Yeah, but at least half of the audience does know about Docker, that's good. I work for Simply Wall Street. We help individual investors make confident investment decisions. I've been there for a bit over 2 years now. We're actually looking for senior backend engineers. If anyone wants to apply, please do. I think there are 2 or 3 people here in Adelaide as well in the iconic. So basically, we let people work from not from Australia, probably also from New Zealand, say, if you want to apply, just pay me. I am originally from Kathmandu, Nepal, the only country that has a non-rectangular flag. Raise of hands of people who identify themselves as Nepali. Not bad. Yeah, and a country that's probably pumping around $4 billion to the Australian economy these days with all the students flowing in. It's not me, it's ABS data. So coming back to the agenda. Today, if you wanna go to the slides, you can scan that. We're gonna go through Google's infrastructure and how it is built to handle billions of users. Next, containers and Docker and why use it. Then a bit about serverless and the reasons to use serverless. Similarly, we'll go into containers without Kubernetes. Because many of you don't know Kubernetes, so let's do containers without Kubernetes and probably add a mix of serverless in that. Then a service that runs your containers, a container as a service by Google. We'll get into that as well, and a demo, and surely come to a conclusion. Let's start then. Google has more than 7 services that has more than 1 billion users. This data is from 2022, as far as I remember. I am not counting Chrome and what else? On Google Play. Chrome and Android as services because they don't need servers, right? Except for that, all the others will need servers, and even in 2022, like half the world was using Google Search. The point here is Google runs everything in containers. Everything that runs on Google is in containers. And they have been using it to deploy software efficiently, to operate in unprecedented scale of like billions of users, while moving fast. And Google manages or orchestrates these containers with a system called Borg, which is not open source, whereas it could be dubbed as a predecessor to Kubernetes, which is an open source project, right? The point here is, running containers at scale. Google does it. Google was probably doing it even before it was democratized with things like Docker. And yeah, by now, I think it is pretty safe to say that Kubernetes is the de facto way to run containers. It is the de facto container orchestrator. Probably towards till 2017, 18, there were other competitors like Apache Mesos, Docker Swarm to run your containers, but like Kubernetes won the war on them in 17, 18, and now it's the de facto way to run your containers. But yeah, with this thing, the thing that I'm talking about most is containers, containers, and containers. So let's look into what they are. As per Docker, they say it's a standard unit of software that packages up code as well as all of its dependencies to make the apps run quickly and reliably. What you get out of this is, if it runs on your machine, 99% of the time it should run on staging in production as well. That's one of the advantages of actually using containers. Docker is a company, is a platform which basically democratized using containers, towards 2013, 14, somewhere like that. Now, there are more reasons to use containers. As I said, one is that you ship the whole stack, right? You ship your code, you ship the dependencies, you ship the software that runs in the right version. For example, like Node 20, and then you ship the OS. So it's the whole thing being shipped and changed every time. Every deployment, the whole thing changes because the whole thing is being deployed. So you ship the whole stack. You just don't change your code or the dependent, like all the other dependencies. Another good advantage of using containers is it's pretty easy to scale horizontally. By that I mean the resource usage is really nice. What I mean by that is, if I happen to run 10 virtual machines on this Mac, it'll likely go up. But if I run like 100 containers on this Mac, it'll still stay up and running. So that's how good it is with managing resources. Containers actually make you more cloud agnostic and or even hyper cloud, ready for multi-cloud, because the install is faster, they are faster than VMs. Not only that, you could move your containers from one cloud provider to the other. One of my previous employers, they moved from Amazon AWS to GCP. And I think that was possible also because everything was running in containers with Docker. Last but not the least, it helps the developers get productive on day one. I remember my days in 2012-13. So what I had to do on day one was to get a Vagrant machine or get a machine, get the exact right version of PHP, the exact right version of Solar, and everything else. And all of that would easily take a couple of days before I could write one line of code. I could be unproductive. Come now, probably you run like 2 compose up commands, you get a coffee, depending on how fast your internet is, you come back and your whole stack is ready and you could be productive on the first day. You could actually deploy some code and get it to production on the first day. So that's a very good advantage from a developer's point of view. Now, looking into this, a Docker file basically is a flat text file that has some commands on it. When it is built, it is called a Docker image, which is a static artifact. It's not even running. As it is a static artifact, you can push it to a container registry. Like, for example, you push code to GitHub. You could push your containers or Docker containers to Docker or any other registry. And then it is pulled and then it is run by de facto Kubernetes or any other container as a service. There are some, probably I'll talk a bit more about it. For now, just keep this picture in your mind. I'll come back to this and then we'll have more details on this from a Google Cloud point of view. How many of you have used feature flags or know something about feature flags? There's a couple of people. So yeah, just to explain it, what I could do is I could write a new feature and have a system or some form of a if condition where I would release that particular feature to only 5 people who are in my team, or 500 people, or 20% of my traffic, or 20% of my users, right? So that's basically a feature flag. And something like that, the traffic management part of it is built into Google Cloud Run UI that you could say, I want to deploy this version only send in 1% of the traffic. Pretty easy. The other thing you could do is you could add a tag to it, and then it gets a preview URL. I don't know if you guys are, has anyone used Vercel or Netlify?
Yep.
Yeah, so they give, like, once you push the code on every pull request, you get a, what it's called, preview URL, right? You could do that with Cloud Run. As long as you can tag it, it gives you a different URL, and then you could just test it without anyone else knowing it, right? So that's the thing. You basically separate deployment from release, and release could be, I want to release it to only 2% of my customers. Okay, things look good, logs look fine, let's go 4, 10, 20, 100. Yeah? And then you could also set concurrency on your containers. A cloud function is basically one request, serve that, die. Right? Cloud function would generally only serve one request, but for serverless containers with Google Cloud Run, you can tell that I want this container to take like 80 requests or 1,000 requests maximum, and then only it goes away. So you could do that, and which makes it a lot more efficient compared to cloud functions. So Google Cloud Run has added more things in the previous years. Cloud Run jobs is basically you can run something like a cron job with Cloud Run a lot easier. There are integrations with Cloud SQL and all the other Google Cloud services. Sidecar containers, anyone knows them. For example, we have a main container and then another container that actually collects the logs and sends it somewhere. That could be a sidecar container. Linkage with cloud storage, health checks, and they are adding a lot of things in the recent years. And another amazing feature with Google Cloud Run is you could go on serverless. By that I mean, you have the minimum instances configuration, right? If you don't set it to 0 and set it to 1, there is no more cold start because there is always one container running. Right? It's very easy to go on serverless with Google Cloud Run. You just have one setting set properly, that's it. Of course, you need to pay for the container because it's running, but yeah, that's another advantage. If you want, you can follow the release notes of Google Cloud Run. I think that takes you to the Google Cloud Run release notes, and they have all the things that they have done with reverse chronological order. Before I go ahead, who has played Fruit Ninja? Jetpack Joyride? Fruit Ninja. Has anyone played Fruit Ninja? There were some people who have played Fruit Ninja and Jetpack Joyride. To my surprise, this is actually made in Australia. There's a company in Brisbane called Heartbreak Studios that actually makes these games. But the point here is they also use Cloud Run, and the lead engineer there, Nick, in one of the Google Cloud customer stories said, but with the use of Cloud Run, they eliminated the need to add another engineer because it was that good and it was more of a set and forget, and all the infrastructure was managed. It's not me, it's probably a $1 million company's lead engineer saying that. Now, I had told you to keep this image in mind. Let's come back to this with a Google Cloud flavor. So to build your containers, you can use Google Cloud Build, right? And that turns your image file into a Docker image. So your Docker file into a Docker image. That could be pushed into artifact registry. Earlier it was called container registry, but they are kind of deprecating it with artifact registry now. And then you could run it with Google Cloud Run, which is the container as a service by Google Cloud, or the hero of the talk. And by default, Google Cloud Run automatically connects with logging and tracing, Google Cloud logging and Google Cloud trace. So by that it means if you have a Node.js application and you do a console log, it automatically goes to Google Cloud logging. You don't need to do anything. Tracing, it provides you, let's say if you get like 100 requests, probably 1 to 40 milliseconds, and something else to 600 milliseconds, you can look at those traces without doing anything, just out of the box. Plus, you could use it with other Google Cloud services like Cloud SQL, pops up, storage, you name it, you could use it with any of those. Okay, time for the demo. There are two, but I'll only do one. I'll show the video for the other. because I'm not great enough to the demo works today. Let's see. So when you click this, it basically goes here, which is a simple API connecting to a database, as long as I could see that. Okay. Just slow. Okay. So when you click that, this open source GitHub repository, that basically connects to a database. The database is not in Cloud SQL, could be, but it is not. That's the thing for now. And yeah, it's a very simple API that gives you out some codes. Now, there are multiple ways to deploy this to Cloud Run, but clicking a button is probably the easiest. And that's what I'm going to do now. So this is going to take me to my Google Cloud platform, even I'm connected to the internet. Okay, it's just fine. Okay, and then for the first thing it tells me is to confirm the repository. I'm going to make the fonts bigger, of course. And what it's doing in the background, it's creating a Cloud Shell machine for me, and from there I'm going to deploy without installing anything. Yeah, that's why I record my demos. So if this doesn't work out, I have a backup. It looks like the internet is not on my side. Okay, this is actually taking long, so let me go back to the backup plan. Yep, so there are Australian companies using Google Cloud Run as well, not only Google Cloud, specifically Google Cloud Run. In addition to Half-Brick Studios, the one that I could get from the Google Cloud customer stories was Pet Circle. They basically said that they could ease their operation and make it become much more cost effective. Similarly, again, Half-Brick Studios, again, they apparently reported that their costs went down from $24 a day to just $4 a day. And yeah, they could serve a wide range of requests per instance. I think it's because of the concurrency mating. Another Aussie company called JRide said that they could process billions of rows with Google Cloud Run by scaling the stateless containers and use the data flow and things like BigQuery. All of these are actual stories on the Google Cloud customer stories. Then Google Cloud Run is also used by hyperscalers. MailChimp, probably most of you have heard the name. It's a very popular email sending service. And they said that they added, with the web services, they added the ability to put automatic scaling to production. Similarly, BBC, I suppose there will be no one who doesn't know this brand, said that they could process 3 billion log lines in a day. What actually happened, the story behind this was when the news of the Queen's death broke, that sent in a lot of requests to BBC, and they saw like in a minute their containers went from 100 to like running from 150 to 200 to more than 1,000 instances. That was almost instant. What I'm trying to say here is, yeah, the upscaling of the containers was pretty good. The second biggest bank in Germany is a bank, also uses Google Cloud Run, and they reported 90% cost saving. And yeah, just to confirm, I went to the website and they actually make a profit of 3.2 billion euros. So yeah, and they also reported the fuel reduce by 70%. I'm specifically mentioning the bank because it's enterprise, very security sensitive, compliance needs to be there, and Google Cloud Run did meet all of those requirements. Again, you don't need Google Cloud Run for scales because big scales, it can also scale to 0. One of our side projects, ADX Jobs, also uses Google Cloud Run mostly. And yeah, in this economic environment, it might be a good thing for you to have a look. Basically, it's a job aggregator that aggregates jobs from 80-odd companies in one place. And yeah, this uses Google Cloud Run for sure. And it uses them serverlessly as well. So coming to the conclusion, I think there are 3 main conclusions out of this you should take home. First one, use containers, but use Kubernetes only when needed. You can start with containers in the cloud without Kubernetes. Next, serverless is useful. Use serverless when it makes sense. For example, you have a staging environment, you work 8 or 9 hours a day. So 16 hours a day, you're paying for that staging environment for no apparent reason, right? You're still paying for 40 to 16 hours a day. So if that was serverless, and then no request was going to your staging environments, you're basically saving the cost of those 16 hours. Yeah? So serverless makes sense, like think in these terms. Last but not the least, let the big companies handle scaling, that being Google in this case, because they know what they're doing. They have, I don't know, hundreds of engineers, SRE engineers who are actually dedicated to that. So yeah, if you can offload your scaling problems to any of the big 3 or any of the clouds and use something like Google Cloud Run, just do it. Thank you. That is my LinkedIn profile if you want to scan in. Yeah, I'm open for questions. I don't know how much time do I have, but yeah, I'm open for questions.
How secure do you feel the containers are?
Who was
how secure do you feel about the containers, like from your point of view, like working with them?
So container security, I think, is a different domain itself. Like there are tools like Sneak and other things that actually help you with your container security, right? So container security, I think, is another thing. But then if you run it on Google Cloud Run, from an infrastructure point of view, I don't think you need to worry much about the security part because it's being handled, because the whole infra is being handled. But as I said, container security is a shared responsibility and a completely different domain, in my opinion. For example, if you have a Node.js library that's 2-year-old and has a lot of known security vulnerabilities or holes, and you're still putting it in your app, that's on your side rather than like the cloud being able to help with anything.
Now, my question is like, how do you choose between Docker and Kubernetes? Like, what features, like, what project do you use Docker or Kubernetes?
Docker and Kubernetes is like comparing apples and oranges, or cats and dogs. But yeah, the thing is like, Docker is an OCI compliant container platform, which helps you convert your Docker files into containers, into images, container images. Sorry, let me go back to the slide that help you. Yeah, so this is the area for Docker, and that is the area for Kubernetes. So if you run a Docker image, then it becomes a container, and if you want 100 copies of that container, then you would need something like Kubernetes, right? Whereas Docker is at this side where you want to package your code so that it can be run with a container orchestrator like Kubernetes. So that's where I find it very, very difficult to compare them. Any more questions?
Hi, currently we are developing some microservice with Google function.
Yep.
And because the microservice, the logic is very simple, so we just use Google function, and I think it's very quick to spin up a new, to serve a new request.
Yep.
So do you see any advantage if we can switch to Cloud Run, or we just
Which version of Cloud Functions are you using?
Cloud function?
V1 or V2?
Maybe V1.
Okay, V1 doesn't use Cloud Run, V2 is just a layer on top of Cloud Run.
Okay.
So if you want to go up, you would anyhow land on Cloud Run. Because if you go from V1 of Google Cloud Functions to V2 of Google Cloud Functions, it just is like a layer on top of Cloud Run. Now, talking about advantages, let's say if you want to use, for example, if you're using Node, and then right now you're at Node 20 with Google Cloud Functions, then whenever Node 22 comes, they are still going to take a month or more for them to go up, right? But if it was a container, you go in, you just change the 20 to 22, build, deploy, you have a Node 22 in production.
Thank you.
Thanks. I don't know if we have time for the questions. We do. Any more questions? So we're done. Thanks.